over this. Looking at his chocolate bar from the top view, Brian states that it looks like a rectangle. State two properties that make the bar a rectangle. So if you have a study sheet, right, you go over, like even if you just have this on your study sheet, you could say, hey, it has two pairs of congruent sides, right? So you write that down. Two pairs of congruent sides, right? Or equal sides, or sides that are the same. I don't care, right? Like I'm gonna be pretty generous there. And the other one, you could say it has four right angles if you want. You can say it has two pairs of parallel sides. This is how you say parallel, if you want to write it that way. It actually is, if you, on page 190, I actually gave it to you that way. Two pairs of parallel sides. Diagonals are congruent. You could have said that. Diagonals bisect each other, right? So in here, diagonals bisect each other, so you could have done that. And both are congruent, right? Both diagonals are congruent. So diagonals bisect, diagonals are congruent, and so forth. Yes? Two pairs? All right, we'll be okay then today. Anything else? Anyways, so properties. Like if you know your properties, you can score a lot of marks that way on this test in particular. Yeah. Yeah, sure. I know what you're saying. All right. Name the following triangles. So this one has two sides that are the same, two angles that are the same. Right? This is an isosceles for sure. And you would have to say it's acute based on the diagram, right? You don't have any other option there. So we'll give you 1 mark for each there. And this one is obtuse because of that, right? So it's obtuse because of angle and scalene if you look at the sides, right? So 1 and 1. So if you follow that little 2 that's up here, cross that off and just make it out of 4. It's easier that way. Okay, sketch a rhombus and label all congruent parts. I will, if you have 2, then you're fine. But rhombus is basically a slanted square, so these would be congruent. Right? This would be same as that. This angle is the same as that. Right? So if you have 2 things that are true, I would give you the marks. Another way of doing this is if the diagonals cross each other, this is the same as that. This is the same as that. And then you can go all around that shape to say that, right, all side lengths are the same around it. So any 2 properties that you labeled, I would give you full 2 marks, right? And the diagonals meet at a 90, right? That's also very particular to a rhombus. A rhombus in a square, that is the case. Next, a kite is a type of polygon. State 2 properties of this polygon. You can say that diagonals are perpendicular. You can do this, or meet at a 90. Right, meet at 90 degrees. You would say that if you look at the kite here, this was on page 191. It has 2 pairs of congruent sides, right? 1 pair here, another pair there. So 2 pairs of congruent sides. You could say that the shorter diagonal is bisected or cut in half. right? You can say that. Like the shorter one here is bisected. Yeah. I told you to think of it as that, but I don't know if I would accept it as a property. All right. So I'm glad to hear you listen. Folks are listening. So what I would say there is you can say it has one pair of congruent angles. There's one pair that is congruent, and they're right across, like where the shorter diagonal is. That's where they meet. Anything else? Just my students tend to school me here, so. Anyway, so we have this page, 2, 4, 6 plus the 4. This is out of 10. This page is out of 10 because we changed question 2 to be out of 4. All right. So properties, properties, properties. No math whatsoever. Martha is building a triangular ramp over a drainage pipe. She's considering the following designs. Choose the letter that best completes the statement below. The type of triangular ramp that allows a wheelbarrow to be pushed smoothly over the pipe with the least amount of effort from either side is, yeah, obtuse. This one here, you are correct. This one here is the best option because you can tell, right, the bigger the top angle is, right, the shallower, the smoother the rise and the, yeah, so C is the right answer there. This could be an isosceles, right? This actually it is an isosceles, right? If you want it to be the same on either side, right? This could also be an isosceles, but it's an acute, right? So it's still steeper than this one, right? So keep that in mind. Okay, justify why this type of triangle should be used for the ramp, making reference to the base angles, right? And you would say something, a greater angle at the top, right, comma, will result in smaller base angles or something like that. A smaller base angle will make it easier to push items up or down. Are we writing an essay, Mr. Erickson? Is that what we're doing here? Is that your introduction to the essay? Now, well, I just want something like that. So just I think if you just write down 3 words or whatever, just because or something, right? Like expand a little bit. Use your vocabulary. If I can in that statement sense that you know what you're talking about, you will get the marks. Okay. All right. Consider the following right trapezoid. So they tell you the name. Calculate the indicated angles or sides. Okay. So I'm going to figure out this first. Remember that these 2 angles on either side of this trapezoid add up to 180. Right? So to get an x is this whole thing here. So x will be 180 minus 50, and that is 130 degrees. Okay? Yes, you could have cut it and then made this 90 here and then figured out the small one here and add 90 and the small one. That also works. Whatever you did, if you came up with 130, you got the answer. Y is technically the height of this trapezoid. I don't know if you caught that, but if you find this, you're actually finding this as well. So I'm going to cut that out. I'm going to put the 50 here. I'm going to put the 90 there. 6 minus 4 is 2 meters. No need to divide. This is 2.5 meters. So I'm going to figure out y here. I'm going to use Pythagorean theorem. If you use the sine law, I know you're going to have a different answer. So I have to change these angles to make sure that it works out. So it's okay if you use sine law, we're going to figure it out. Okay, so leg squared is hypotenuse squared minus the other leg squared. And let me just type this in real quick. That's 2.25. So taking the square root of that is 1.5 meters. Sine law, what did you get? I know Lawrence, you used sine law. You got something else, right? What is it? 1.92. Let me check. So if you use that pair, sine of 90, and then it's sine of 50. I had to think of the sine law there for a moment. Cross multiply and divide. So it's 2.5 times sine of 50 divided by sine of 90, which is 1. So 2.5 times sine of 50, 1.92. Yeah. And you know why this happens? I used to teach geometry before trig. And so that was never an issue. Students would even try to use sine law. And then I switched it, and now I have to make sure it adds up or else, right? I just made this up, right? And I have to make sure it works out. Yeah. Oh my goodness. What do you get with cosine law? 1.96? If you use cosine law, it's 1.96. I'm just going to take your word for it there. Oh my goodness. Anyways, so I think this angle, for it to work out, I think it's 39 degrees. If this had been 39, we would all get the same answer. So I will fix. I already did fix it this morning. So next year, if you take this again, it won't happen. All right. I don't want to take this again. Okay, so where are the marks allocated here? You get 1 mark for getting the 130. I would say you get 1 mark for coming up with this triangle because you have to subtract, right, to get the 2, and you get another mark for using Pythagorean theorem or sine law, right? Whatever. So 1, 2, 3, 3 marks here for the various steps, right? So this page is out of 5. So 10 and 5, it's out of 15 total, right? Add it up. Put your name, first name and last name. What's that? Yeah, the whole thing is out of 15. So let's get rid of the 13. Okay. And let's go to, pass it forward first of all. Yeah, 5 corrections, and then we move on to polygons. So let's see how much we cover. Let me just have this ready here. Okay, so using your knowledge of the properties of quadrilaterals, we did triangles first, not quads, right? Find the measures of the indicated sides angles, okay? 195. So side Y is going to be, these are the same, so that's just 2.4 feet. There's no math there, just know your properties. Angle X, how would I find that? Knowing that these two angles on the same side of the quadrilateral always add up to 180 degrees. So to find X, I would just go 180 minus 118. And that is 62. I got that. I got this. Morning, morning. 195. Angle Z. X and Z are the same, right? It's basically a copy on the other side. Go ahead, Lawrence.
What is that? Find the angle, like, if you know the angle, like 180, can we use the angle of elevation in that? And angle of deflection?
So you use this, and then this would be an angle of elevation, yes.
Yeah. then you make a vertical line with the 118 outside of it.
Here, oh, like this?
Yeah, yeah.
Yes. It just gets, I'm not going to talk about it now, but yes. Technically this is 118 here, right?
Yeah.
And then you can subtract from 180. You're doing the same thing essentially, yeah. Yeah, that's fine. Z is 62. It's the same. These are the same, right? By definition. So once I found X using this property, I was able to just transfer. That's it. We're good there. Yep. 360 minus 2 times 118, yeah? And then divided that by 2. You got the same. Yes. You're paying attention, right? So Kim J, I'm just going to say quickly, he knows that all angles add up to 360. So he went 360 minus 118, and then divided that rest by 2 and still got this. Okay, so that works absolutely. Yeah. Next, this is a right trapezoid. It doesn't have these markings on there, but you can feel free to add them. And so Y, angle Y, I will do that first. These two add up to 180. Right? I know that is always true. Or you go 360 minus 90 minus 90 minus 24, you are left with that, right? So you go 180 minus 24, that's 156. 156. So we got that figured out. X here, you have to be careful. Some of you use sine law, and that's again going to be a bit of a problem. But if I make a cut here, I know that 6.2 is right here. And to get this here, I'm just going to go 8.4 minus 4.7. And that gives me 3.7, which I'm going to introduce here, 3.7. Right? This is a 90. So to figure out x, which is in this case the hypotenuse, you got to be very careful. Hypotenuse is 6.2 squared, right? The leg plus the other leg. You got to add them. And then you take the square root of that, which is 52.13, which gives you 7.22 inches. If you use sine law, you get something else, right? Lawrence, you got something else yesterday? Or did you go back to Pythagorean theorem? I will make sure it works out for the test. I promise you that.
But I had like a really big number.
Yeah, it could be. Yeah, it could be. If you think about it, this doesn't even look close to a 24, does it? 24, like if you think of this being a 90, sorry, this is a 90 right here. Half of it would be 45. Half of that would be 22.5, so it should look more like this, right? So shame on Mr. Dirksen for not picking that up. Anyways, am I done there? Yes, I'm done. Okay, next. This is your kite here. Watch this. You need to be comfortable with that. It's saying that stretch AC is 10. So from here to here, it's 10. And what do we know about this shorter diagonal here? It's cut in half, right? So this is 5 and this is 5. So whatever this is, just divide it in 2 and then you find that. So I'm going to cut out this little triangle here. This is y, which is 7, sorry. I know that this is 7 and this is 7 here automatically because they're the same. So y is 7 meters. Let's state that there. So now I know this is 7. This is x. This is a 90 there. And this is 5. I'm missing one of the legs. So that's x squared is equal to 7 squared minus 5 squared, which is square root of 24. And that is 4.90 meters. So you found x. Side z, which is right here, it's opposite to the other congruent side. Side z is just 18 meters. Okay, I'm going to cut this here. And I'm going to take out one of these here, the longer ones down here. I know that this is 18, this is 5, and P is right there. P is also one of the legs, right? So P squared is going to be 18 squared minus 5 squared. P is 299. So P is 17.29 meters. So you found everything in terms of side lengths. It's all done. I'm going to kind of block this off there. And now the more challenging part, which is, I don't know if you caught that, but ABD, it's asking for, right, A, B, D. It's like if you were to connect these 3 points, that's the angle that they want. So what I'm going to do is try to sketch it to the best of my ability here. This is what they want. I'm going to call this M, angle M, lowercase. I know this is 7, this is 18. And what will this be here? From here all the way to here, I need to add 1729. I know this is a bit challenging, right? Like this is 4.9, this is 17.29. So I'm going to add that up. Where will I show that work? I'll just do this. 4.9 plus 17.29. Just so I don't make any mistakes. 22, 19. Okay. And so this is 2219 here. That side right there. So now I have side, 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 right? So I want to find angle M. So cosine of M is going to be minus 18 squared, right? I make sure that the side across from it is here. Then I'm going to go 7 squared plus 22.19 squared. And down here is 2 times 7 times 22.19. And I will quickly type that in. 49 plus 22.19 squared minus 18 squared. That is 217.3961 over 14 times 2219. That's 310.66, which is 0.69, and that keeps going. So angle M is cosine inverse of 0.6997, so forth. Oh my goodness, I didn't leave enough room there. So I'm just going to use cosine inverse. That's 45.59. That was a lot of work for that, right? And we forgot a little bit how to use cosine law. So this is a good way to review how to do that. And there was a lot involved here. So on a test, I don't know if I would just do it all in one shot. I'll make you do it in steps. Yeah.
I did cosine too, but I just used the top triangle.
Oh, yeah. So you use. Oh, you divided it by 2. Okay, then yes. Yes. Yeah. You use this one here? Yeah. Did you get the same? Yeah, by 0.1? Oh, yeah. Yeah. All good. Good. Yeah. Yeah, we're good. But you still have to use cosine law, right? Probably, yeah, that was probably easier to do it that way. Yeah. You'd saved you this step here. Yeah. Because you only add 10 there. 5 and 5. All right. Let's leave this one for now because I have examples on this. I will come back to it later on. So 196, we're leaving it. I want to make sure 199 and 200, I'd probably give you some time tomorrow to review that. So let's go to polygons, which is on 203. Today's Tuesday, right? Yeah, okay, we're good. I want to talk about regular polygons in particular. Here's what the definition of a polygon is. Polygon is a closed figure formed by joining 3 or more line segments at their endpoints. So polygons has everything in it, all the shapes that we've used. Go ahead. So we have triangle, quadrilateral, and we have pentagon, hexagon, right? And so this is the number of sides that go with each. You should know these ones. Like if I ever throw like find this for a hexagon, you should be able to tell me how many sides. Can you write this down? Number of sides is denoted by the letter N. So number of sides in math for polygons, we use the letter N. Okay. If all sides, watch, this is worth highlighting or underlining. If all sides of a polygon are equal and all angles are equal, it is called a regular polygon. So for example, a square, all sides would be equal and all angles would be equal, correct? All sides are equal, all angles are equal. So it's regular. Let's just go poly, okay? So if that is a check mark and that is a check mark, then you can say it's a regular polygon. What about a rectangle? All 4 angles are the same, aren't they? But this side is the same as this. This side is the same as that. So a rectangle would not be a regular polygon by definition. Okay? I would say this. Some sides are congruent. All angles are congruent. But because it fails this one, right? It fails the sides being congruent, therefore not regular. I would say irregular, sorry. Same with triangles. Equilateral would be, isosceles would not be, right? Scalene for sure wouldn't be, right? But that's just it. You need to know if I ask you like a multiple choice or something like that, you need to know what does it mean to be regular when it comes to polygons, okay? So have that down. And then I'm gonna give you a bunch of formulas which are found on our formula sheet as well. So I would say these formulas, I would just have my formula sheet on me. Don't add it to your study sheet because it will take up too much room. That's my opinion. But if you know how to compress it, sure. The properties, those I would have on page 190, those I would have on my study sheet. Because 2 units from now, 3 units from now, you're gonna have a hard time recalling those, okay? So here we go. I inserted this worksheet into the booklet. It's all in one place. And remember, there are 5 formulas. I tried to use psyched. You're psyched for this, right? Not really, but sum, interior, central, exterior, diagonals. Don't worry about it so much. I'm going to talk about it just now. What's the sum of all interior angles of any polygon? It's this, n minus 2. Yeah. Right. N minus 2 times 180 degrees. That's the formula that will give you the sum of all interior angles. Let's try it out. Triangle, how many sides does a triangle have? 3, right? 3 minus 2 is 1. 1 times 180 is 180 degrees. And a triangle does add up to 180 degrees every time. And if it's a 4-sided shape, it'd be 4 minus 2, that's 2, times 180, that's 360. A 4-sided shape always adds up to 360. So this is always true. Okay? Each interior angle would be like this. It starts exactly the same. Watch. Then it's exactly the same as before, except for we're going to have to divide that by the number of sides. So this is the formula that gives you each interior angle of a polygon. Can we go over here, and I will just pick one. This is an interior angle right there. This is another interior angle. So a pentagon has 5 sides and 5 interior angles. So interior, interior, it's all over, right? On a triangle here, this would be interior. It has 3 sides and 3 interior angles. Always the case. Okay. Central angle is very easy. 360 degrees divided by the number of sides. And you need to know where they are, because I will ask you to label it. Okay? So watch this. The central angle is right here. Find the middle. Just put a dot right in the middle of that shape. And then just go to one corner, bring it to the center, and then go straight to the other corner. So one of the side lengths is one of the sides of that triangle just created. This is a central angle right there. Put a C there. Okay. How many central angles are there? You can actually fill this in. There are 1, 2, 3, 4, 5, 6. 6 sides, 6 central angles. But you only label one of them because we're just finding one. So a full circle is 360 degrees. And if you divide it by the number of sides, you get how much one of them would be equal to. Let's do it here as well. Find a center. I'm just going to label one of them. That's a central angle right there. Let's do this here. N is equal to 1, 2, 3, 4, 5, 6. This one has 6 sides. N over here, 1, 2, 3, 4, 5 sides. Okay. This one is N is equal to 5. This is also a 5-sided. It's a pentagon. We don't need to do that for the triangle. I think we all know that. exterior angle, you're going to love this. It's also 360 divided by n. It's exactly the same as central angle. This is right after page 203, Raphael. This is where it gets a little trickier. The exterior angle, think of the word exterior. It's going to be outside, okay? So watch this. On a triangle, for example, take one side, for example, and go along it, and then you get to the corner, just extend that side. Just follow along this one and just extend it, make it dashed. That angle right here, between that dashed line you just created and one of the sides, it's called the exterior angle right there. Let's travel down this side, and then you keep extending it. As if you've missed the turn, right? And you just keep going. That's another exterior angle right there. Let's do the same thing with the base here. Once you get to the corner, just extend it. And that's your exterior angle right there. How many exterior angles? 3, right? 3 sides. How many interior angles would this have? 1, 2, 3. So how many central angles? Would be 3 as well, okay? Let's do the same. Let's just label 1 here. So if I asked you this right here, label 1 exterior angle. Pick any side. So close your eyes and just go that one, okay? It doesn't matter which way you want to travel. You want to travel this way or that way, it doesn't matter. Just as soon as you hit the corner, just extend it like that, as if it's a straight line. You should be able to go with a ruler, and it should be like in line with that ruler. And then just go ahead and put one of these in there and say that that is the exterior angle. Let's go ahead around the whole shape and do that. It doesn't hurt. It's like a wheel, right? Water wheel. This is what it isn't. This is not an exterior angle. Listen, look up here carefully. I'm going to erase it. Some students are like, it's not an exterior angle. You need to be able to travel along one of the sides and extend it like that. It doesn't matter which way, but this is not an exterior angle, okay? So make sure it's the extension of one of the sides going outside the shape. Number of diagonals, this one is tricky. It's n times n minus 3 divided by 2. Now, what in the world are diagonals? You should know, you should have heard it already, but I'm going to use a different color here. Watch this. I'm going to start at the top. You connect one corner to the other corner without doubling up. So from this corner, I can go this way and that way. That's it. Then I'm going to use a blue pen. I'm going to go over to this corner. I can go across this way. That's 1, 2. So there's 4 diagonals so far. And the last one I'm going to do with a highlighter. This is the only one left. So if you count, there are 5 diagonals. So this formula will allow you to calculate how many diagonals there are, because the more sides it has, the more diagonals, and it goes into the hundreds. I would not expect you to draw over 100 diagonals, right? That would just be counterproductive, right? It wouldn't make sense. So let's do a few calculations here. It's not that hard, guys, if you just know what you're supposed to do. So watch here. Calculate the interior angle, the exterior angle, the central angle of the following. Label them in the polygon using ICE, right? ICE can always be labeled. the first thing you want to do is count the number of sides. This is how I do it because it gets to like 12, 13, 15 sides. You can put a check mark where you start, right? So that's 1, 2, 3, 4, 5. I used a pentagon. I know I should have used different shapes, but it's just to make the point, right? So 5 sides. Let's get this labeling underway first. So I'm going to pick any one of these and call them I. That's an interior angle. For the central angle, you go to the middle and you go like this to one corner and to the other corner. It should be a pizza slice like that. And then right there, you label that C. Okay. Exterior angle, go along the side and just extend that side like this. And that's where your exterior angle is located. Okay. So which one do you want to do first? It doesn't matter. I'm going to do interior, which is n minus 2 times 180 divided by n. I'm going to zoom into that right now. So that would be 5 minus 2 times 180 divided by 5. I is equal to 3 times 180 divided by 5. And so, right, just go 3 times 180 divided by 5. That's 108 degrees. So every single interior angle on this regular pentagon is 108 degrees. Okay, cut this. These ones are easy. Central angle. Let's do the exterior first because there's a point I want to make. Sorry, exterior is 360 divided by n. Exterior is 360 divided by 5. Exterior is going to be 72 degrees. Do you notice something about these two angles, the interior and the exterior? What would they add up to? 180. Look at this, folks, here, right here. Just look at the screen one more time. Let's put the eye. You know how I have that exterior angle there? Let's complete that and call that I. Do you see how they're next to each other and they would always add up to 180 in every single corner? So that is sometimes a useful fact, right? Note E plus I is equal to 180. It's supplementary, okay? Let's stop doing there. There we go. This is also a formula you can add. Let's see. E plus I is equal to 180. These two always add up to 180. One more here. The central angle is also 360 divided by n, which is 360 divided by 5, which we already know is 72. No, sorry, C. So there's that. There's one more that I want you to calculate because I didn't. I want you to be able to do that. It's not that difficult. The sum of all interior angles of this shape, what would that be? Let me zoom out a bit. Let's do that right here. Sum would be n minus 2 times 180 degrees, right? So sum in this case would be 5 minus 2 times 180. Sum is 3 times 180. Sum is 500. Let me just check that. 540, that's what I was going to say, but so the sum of every interior angle, if you add them all up, would be 540. Each interior angle is 108. Each exterior angle is 72. Each central angle would be 72 as well. Okay. So make sure you write that down. And I want you to practice on the back side, there are 2 questions. Do at least one. Okay? That I promise works out. Those do work out. Just do 2 and 3 here, real quick. Find the sum, the interior, the central, the exterior.